Section 7.1, Solving trig equations with identities. Your homework is 5 through 33, every other odd. To begin, let's recall some identities that we have established. We have the Pythagorean identities, which read cosine squared theta plus sine squared theta equal 1. And we have other similar trig identities. We have our even and odd functions, reciprocal identities, and quotient identities. With all this information in mind, we can now begin the process of proving trig identities. Now, steps for verifying trig identities. Work on one side of the equation. It's usually better to start with the more ugly looking, more complex looking side. It's easier to simplify than to build up. That's why. 2, look for opportunities to factor an expression, square a binomial, or add fractions. Noting which functions are in the final expression, look for opportunities to use the identities that make up their proper substitutions. And 4, if these steps do not yield desired result, try converting all items to sine and cosine. And honestly, I would make this your step 1. If you don't know where to start with making everything sine and cosine. Now, we're going to use all of this that we have established so far, and feel free to just print this out, have it handy. I should have some cheat sheet in your modules. Use that as well. All right, so I want to show that tangent theta times cosine theta equals sine theta. All right, I don't know where to start. Whenever you feel like you don't know where to start, try changing everything to sine and cosine. Well, tangent, we know tangent is sine over cosine. And we bring down our other one, we have cosine theta. Well, isn't cosine divided by cosine just 1? If you can't catch it, you can rewrite it to be sine theta cosine theta divided by cosine theta. Okay, then you might see, yeah, those things cross out to make 1. So that we just have sine theta equals sine theta. Pretty cool, right? What about this one? 1 plus sine squared, 1 plus sine negative 1 equals, I think I read that one wrong. 1 plus sine of x times 1 plus sine negative 1 equals cosine squared x. All right, well, we see that I have a negative from our argument of sines. If you recall your even and odd identities, if we have a negative for sine is odd, so I can go ahead and factor out or move that negative to the front. So that we have 1 plus sine of x. I have 1 plus, and we can move that 1 to the front. So it would actually be 1 minus sine of, I think I meant for that to be an x, not a 1, of x. Okay, well, I don't know what to do here, but they're differences of squares, so I can multiply them out. We have a plus and a minus, they're conjugates, so this is 1 squared minus sine squared x. And sine squared x gives us 1 minus sine squared x. Recalling your Pythagorean identities, that gives us our desired cosine. Cosine squared x equals cosine squared x. So we have proved it. Now, one important thing about verifying identities, trig identities, is you can't treat your equation where you can move things from one side to the other. You have to keep everything strictly on the left side or on the right side. You can't move them around. Next, we want to show that secant squared minus 1 divided by secant squared equals sine squared. All right, well, that secant squared theta minus 1, it's not something that seems like I can work with. Is that a Pythagorean identity in disguise, perhaps? Well, take a look at your Pythagorean identities. Secant squared minus 1. Do I have a secant squared minus 1? Well, I guess we could, right? If I do a minus 1 on both sides, I'm left with tangent squared theta equals secant squared theta minus 1. So I can replace my secant squared minus 1 with a tangent squared. All right, so I have tangent squared theta divided by secant squared theta. And our goal is to make that a sine. I'm still pretty stumped. So why don't we take the time to write it as in terms of sine and cosine. So tangent squared would be sine over cosine, sine squared over cosine. And secant is 1 over cosine. All right, now let's rewrite this division. We have sine squared theta divided by cosine squared theta divided by 1 over cosine squared theta. Let's see about our fractions. We have sine squared theta divided by cosine squared theta times cosine squared theta over 1. We divide those out, and we're left with just sine squared theta, which is what we want. And if you look at your notes, you could have approached it totally differently. The wonderful thing about working with proving identities is that it's never the same path, for example, as your neighbor. Not to say never, but different approaches are okay. Let's do one more. Sine squared of negative theta minus cosine squared of negative theta divided by sine of negative theta minus cosine of negative theta. So it might be worth noting that the negatives and that come with even and odd functions and how they work. So look at your even and odd functions. That's from that first page. You see that sine, my negative pulls forward, and for cosine, if I have a negative value, it doesn't transfer over, it doesn't stay. So that we have this negative ends up being negative sine squared theta minus cosine squared theta divided by, I can move this negative forward, so I have negative sine theta, and this negative is actually going to cross out because it's cosine, so minus cosine theta. All right. Now, I noticed that I have squares with subtraction. So if I think of this sign as holding on to that, I actually have differences of squares. So this gives me sine theta minus cosine theta times sine theta plus cosine theta. And I got to stop for a moment because this square applies to everything. So it makes this sign actually positive at some point. Because sine squared theta is the same as sine theta quantity squared. It's squaring our entire sine value. All right, moving forward, divided by negative sine theta minus cosine theta. Okay, well, it doesn't look like anything we have so far, but we can factor a negative from our denominator. And if we factor a negative sign, we're left with sine theta minus cosine theta, sine theta plus cosine theta, divided by negative 1, or negative sine theta plus cosine theta, and now I can divide those because they make 1. So then I'm left with sine theta minus cosine theta divided by negative 1, which just causes a sign change. So that I have negative sine theta plus cosine theta. And what are we looking for? Cosine minus sine. We just swap the order. Cosine theta minus sine theta. That's this problem. One more. Let's verify this identity. Whoa, actually this one's a typo. I wrote down the first step, not the problem. It's supposed to equal 1. But I'm okay with the problems we've done. So this was 7.1, trig equations with identities. Thank you.